All right, got my mug up here in the corner real quick for this is Thursday, August. What is it? 31st. I got paid last night at midnight. If that's if the system was working, I know some of you had some Blackboard issues. So I hope I got paid. Um, anyway, I never know. Anyway, welcome. This is mini lesson 4, and what we're going to be talking about is power. What do we mean by power? And then we're kind of doing things a little bit backwards than what we do in a normal physics class, and it seems to work. So maybe I should adapt. In fact, I've always thought that if I just took this class and made it physics 210, even though for my 200 level physics class, even though it is not dumbed down. I mean, it's just not as much information in such a shorter time. The stuff is still intellectually challenging. It's just not as much stuff as we cover there. Anyway, but I think if my students, in fact, I've had my physics 210 and 220 students take this class because they just need an extra science credit or they're trying to boost their science GPA. So I think I got some out there now. It helps boost their science GPA for applications to medical and dental and pharmacy school. They actually learn, the ones I've talked to said, well, I actually learned physics when I was taking this class. Anyway, we're going to talk about power, and and what I've done is I've separated out what the two weightlifting techniques that I found and showed you. If you want to watch those little minute and a half or videos, you may, and the same with the rock climbing guy when we look at the power. But basically what power is, it's the amount of work you're doing divided by the time. Okay, so if you do 300 joules of work, and we really haven't defined force times distance is what work is, and we'll define it in this video. But anyway, welcome, and let's get started before this thing kicks me out, because whenever I have this on with that little ladybug document camera thing and the other thing, this kind of goes south on me really quick. All right, so let's look at weightlifting. All right, and there's the two videos of the weightlifting down below if you want to take. There's the snatch, which is actually the second video I think I have listed there. You can watch that, and then the last one's a clean and jerk. You lift the snatch and the barbell is overhead in one continuous movement. I mean, that takes great coordination, extreme strength to do. And the clean and jerk. Oh, by the way, I'm trying to make, I'm not pandering. Please don't take it as pandering. But I just think too many times in these sports things, it's all men. These are women doing the weightlifting, and it's becoming very popular among women in this day and age. Okay, well, here's some records. Notice this is the records here on Earth. He would lift a lot more kilograms than that on the moon. But I hesitate because we know that kilograms and weight are not the same thing. But here on Earth, it is the same thing. So keep everything. So remember, basically, to get a ballpark figure, of how many kilograms this is, multiply it by about 2.2, okay, or even 2, just to get a ballpark. So that's almost 500 pounds on the clean and jerk, and on the snatch, that's almost 450 pounds. Whoa, that's amazing. All right, weightlifting and work. Here's a prelude. If a weightlifter doing the snatch lifts 77 kilograms, 2.5 meters, how much work does he do? I'm going to jump right in right now with the ladybug, and then then this will be part 1. I just don't want to kind of flash through the slide. I want you to see how it's actually written out. So here we go. The mass, 77.5 kilograms. Okay, and how far did he say he's going to lift that? 2.5 meters. How much work is done? The height, or the distance it's going to go, is 2.5 meters. Okay, so right away, those of you that are new to science and everything, you're going, oh my God, here we go again. I have no idea what he's talking about. Okay, this is just your mass. These are just, we're not using this nice simple numbers or nice round numbers like I like to use in my 210 physics class where I'm making stuff up. I use numbers like 3 and 8 and stuff like that. But these are actual things. So what is the weight that he is lifting? Well, the weight that he's lifting is the force. And the force that he's got to overcome is the mass times acceleration, which is the acceleration is due to gravity, so it's 9.8 meters per second squared. Okay, that's what he's got. That's gravity pulling us down. We'll talk a lot more about that throughout this course. Okay, and work is equal to the force times the distance parallel to each other. Okay, parallel to each other. So this person is lifting the weight, is applying the force this way. The distance is going this way. Notice they're parallel to each other. Okay? Notice they're parallel to each other. So if he's pushing a crate across a surface, say he's pushing on a crate this way and it's moving. Let's say it's moving at a nice constant velocity this way. All right, so it's moving. How much work is gravity doing, which is pulling down, which is the weight of the thing? Weight's pulling down. 0. Work done by gravity, 0. Why? Because it's moving in this direction. The force is going in this direction. So the work done by gravity is perpendicular to that. Work done by gravity, 0. Kind of got ahead of myself there. Okay. So, well, let's just go back to this problem then. So the force, the weight, or the force that he's lifting at is going to be 77.5 mass times acceleration times 9.8. That gives you the weight that he's lifting, and which is also the force. And so the work done is the weight that he's lifting times the height that he lifted it, or F times D. Okay, so 77.5 times 9.8 times 2.5 meters. And let me grab my calculator, which is not near me. It never is when I'm teaching you all. So there we go. On 77.5 times 9.8 times 2.5 equals 1,898.75. Let's just call it 1,900. It was 1898.75 joules. Let's just call it for ballpark for 1,900 joules. Okay? And he had to move that over a distance. All right. In the next slide, you'll see if that's what happened.